So yesterday we have studied about biomass, what is biomass energy, and how different forms of biomass that can be converted into energy. And so today we are actually focusing only biofuel and the biogas particularly. Though these are the nothing from other than only biomass, and biomass is converted into different forms, like just reminding it is can converted into either heat or electricity through different medium. For example, biomass can be converted into biofuel, biogas, and different forms like anaerobic digestion, anaerobic digestions, all the things. So today we are going to focus only that biofuel, and that is called biogas. Let me share my screen. Is it visible to all of you? My screen?
Yes, sir.
Okay. So biogas is something that can be derived from of biomass. First, biomass is under process either aerobic or anaerobic. As last class we have discussed, if it is processed in aerobic conditions, then it converted into different form. That may be by the degradation of the biomass by this microorganism, and the biogas is mostly when it is in aerobic conditions it is digest, then methane gas is formed, like example gobar gas plant. That is a form of biogas, but not only it is when aerobic conditions it is digestion takes place, then some deep in biogas reactor or biogasifier, if we have seen in the last class, then lots of low energy gases can be converted from those the high biomass. For example, carbon monoxides and any other gases, mostly hydrogen. So these hydrogen and carbon monoxides are also called the biogas. So let's uh, see what is biogas. So it is a clean environment friendly fuel. So biogas is nothing but a part of biofuel. So do not confuse about biomass, biofuel, and biogas. Biomass is the broader term. Biofuel is derived from biomass, and biogas is the a part of biofuel. So broader term is biomass, then biofuel, then biogas. And biogas is also having different parts like aerobic and anaerobic. It is aerobic, then hydrogen and carbon monoxide is formed, and it is anaerobic, then methane gas, mostly methane, butane, propane, all are formed. So it is a clean environment friendly gases, because whatever the fossil fuel we are burning, after burning what happened, they generate lots of pollutant gases which releases to atmosphere or environment, produce a worse environment, or air quality will be degraded. But when you burn this biofuel or biogas, what happened? The out product or the byproduct or pollutant, they are very from very little or nothing. So that is called an environmental friendly fuel, mean produce less amount of air pollution when it is burned or biogas utilized. So how it is utilized or how it is generated? When it is obtained by anaerobic digestions of animal residue or animal or domestic waste, farm waste, evidently available in our countryside. So in our village sites, in our countrysides, in our rural area, so every house has, they have their own cattle and animals, livestock in our home. So they are every day they are producing a lot amount of either waste as a food waste, fodder waste, and also the manure waste. So these are normally we are discarded in our field or utilized as a manure. But when it is anaerobically digested in a digester, that produce biogas as well as manure both. So it is a very good sources of biomass that can be found in every countryside or village sides in their home. So, and it is also environment friendly gases. Where methane is the clean energy, one is constituent of biogas, has a great potential alternative fuel. So in your kitchen, you have the LPG cylinder, and likewise the methane, it contains a major percent of methane gases. So the biogas, or mainly when the manure or renewable manure is converted, digested aerobically in digester, it produces mostly the biogas, which is main percentage is methane only. And when methane completely burns, it does not produce any harmful gases. So it only produces carbon dioxide and water in the byproduct. So it is a clean energy. No salts, SOx, NOx, and all volatile organic carbon cannot be emitted. So it is a clean energy rather than other. That means it have the ability to burn completely a combustible, fully combustible gases, methane. So have you mark also, if you are burning wood, then a lot of fume and lot of gases are generated, and as compared to when is burn the gas stove or in the LPG cylinder, there is no smokes at all. So it is called as clean gases as compared to the wood. So both are the form of biomass, because wood is itself a biomass, but when it's converted into biogas, then it is a clean energy, a safer energy compared to the raw material wood itself. So the natural generation of biogas is an important part of this form. So the natural generation of biogas important part of the biogeochemical carbon cycle. So carbon cycle, what is carbon cycle? Then what is biogeochemical? You have to in your science classes, you have to remember that the carbon dioxide, oxygen, then nitrogen, all these are circulate from atmosphere to environment, and environment, then again it is comes into enters into the animals or plants life, then again when they are decay, dead and decay, again they are released into environment. So this carbon cycle is also part of this biogeochemical cycle. That means biogeo means it consisting of the both living and non-living parts, and this geo means living earth, which is the mainly when the body of these animals or plants, they become dead, they are decomposed in and mixed with the soil itself by different chemical processes. That's why it is called biogeochemical cycle. And here carbon is the main source to recycle from the soil to again environment to the living body. So this natural biogas generation is the part of this type of biogeochemical cycle, because the living organism or biomass nothing but the carbon source, main carbon source, because it is organic carbon. So organic carbon, when it is completely converted into biogas, and it is a recyclable process of this carbon, which is the form of methane, where methane is formalized CH4. So the C content, the carbon content, that can be a hydrocarbon that can be circulated through environment. Second is the living body, and third is the soil. So in these three components, it can be circulated easily. If you are born this biogas, it is mixed with air as carbon dioxide by producing lots of energy. Again, this carbon dioxide is taken by the green plants as a part of the photosynthesis processes, and again converted into biomass. And again the biomass is decomposed and formed biogas. And again this is a cyclic process. And this process is called the biogeochemical carbon cycle. So methanogens, methane producing bacteria are the last link to the chain of the microorganism to degrade organic materials, return to decomposition products to the environment. So the decomposition product, that means the bacteria which are mainly converted the biomass or manure to biogas, and the bacteria are called methanogenesis bacteria. That is methane producing bacteria. They eat in anaerobic condition. What happen in the digester or biogas plants? The bacteria which are can be eat the biomass, and byproduct they are producing methane gases, and the methane gases is stored in this reactor, and we are utilizing it in biogas. So this methanogenic bacteria, that is called methanogen bacteria, these are the last link, because the dead organic carbon is converted by this methane by this kind of bacteria. These are called methanogens or methanogenic bacteria, which can convert biomass into methane. Biomass means the dead or dead biomass, or this manure, which is nothing but the mixture of biogas, sorry, biomass, which is converted into biogas. So this is done by these methanogens or methane producing bacteria. So average calorific value of biogas is 20 millijoule per meter cube, as a megajoule per meter cube. So that means biogas having higher calorific value. Last class we have already discussed that everything, every energy or biomass has its own calorific value. That means how much energy can be drawn from the unit amount or unit volume of the biomass. As compared to the biomass itself, the calorific value is very less. That is almost 1 to 2 or 3 and 4, maximum 5 megajoule per meter cube. But same 1 kg of biomass you are consider, then it is 20 megajoule per meter cube. So this is very much high. There is 3 and 4 fold, 5 fold rather, as compared to the biomass itself. So biogas is the most concentrated form of this energy of the biomass. We can say it. Then this is also a important question. The biogas is methane is the major part of this biogas. So what other gases may be present in the biomass? What is the compositions? So biogas is 40 to 70% methane, then carbon dioxide is 25 to 55%, and other gases include around 2 to 7% like nitrogen, hydrogen, and hydrogen sulfide. Because the biogas, majority of the biogas is a part of the methane, is the major part of the biogas, so it is having high calorific value. So this other carbon dioxide, nitrogen, hydrogen, these are very low quantity of found in itself. So methane is the major content. You have to remember that percentage of methane is 40 to 70. Is the high quality of biogas, that up to 70% methane is present in the biogas. So production process, how this biogas can be produced from the biomass. So this is the important part, that is biomass is converted into biogas. What is the process? And this process is mostly important. So what is the process? The typical biogas system consists of following components. That means the process consisting of two parts. First is manure collection, meant the cow dung collection. That is gobar gas also a part, the component of the biogas. That is, it is also called biogas formation, gobar gas plant. So not only the gobar, you can use any waste material, food material, or many any biomass can be converted into biogases. So first is the manure collections. Second is the digestion, that is consisting of both aerobic and anaerobic. So biological processes includes, because the digestion process what happened, as we have already discussed, due to the presence of the methanogenic bacteria, they are converted the biomass to methane with the help of the degradation of by these methanogenic bacteria. So these biological processes are again three types: hydrolysis, acidification, and methanogenesis. Firstly, you have to collect the all manure or biomass, and the biomass is fed into the biogas digester or digestion tank with the help of this microorganism. That means to grow the microorganisms, three processes are there. Hydrolysis. Hydrolysis means to add the water. You have to add the biomass or manure along with a lot amount of water to make a slurry. In like in gobar glass plant, the cattle dung is mixed with the water to form a slurry. That is called hydrolysis. This means addition of water along with the biomass. Second is called acidification. When the acid means when the water is added with this manure. Second point is acidification. The acidity or the pH is increased due to the decompositions of water as H plus and OH minus ion. And sometimes what's happened, this manure or this biomass having some acidic property, so it is shifted toward the basic to acid formation, and this is called acidification. And lastly, with the help of the methanogenesis bacteria, the biomass can convert it into methane, because methane is the main product of this biogas. So then it is consist of a digestion process, then effluent storage. After this conversion process of a biomass or manure into biogas, whatever the left is slurry is remain, it can be out as a manure, or that water along with the slurry is called as effluent. And effluent, you have to process the effluent, because you cannot directly discharge the effluent into this water body. So you have to either dry it, or you have to utilize as a manure in your field. So this is called effluent storage. You have to keep storage or handle the effluent after the formation of this biogas. Second is called gas handling. When the gas is produced, you have to have separate unit for take out the gas from this disaster tank, and you have to store in the particular unit, or and also you have to use, either you have to use this biogas for cooking purpose, for lighting purpose, and for producing electricity. Anything can be used. Then this gas use, obviously the gas can be used either storage or directly can be used. See, this is a typical anaerobic digestion process or biogas processes. Here, the manure we have to add into this biogas tank by adding the water. So this is a slurry. Biogas manure or the manure slurry is injected or adding to the biogas plant, or this is called biogas disaster tank, and where the biogas disaster tank is completely covered with this strong roof, and it is devoid of oxygen. So inside what happens, this manure is decomposed into carbon dioxide and methane gas by the help of this methanogenesis bacteria. And it the gas which are evolves as a bubble form and stored in the upper part of the biogas tank. This is the gas tank. And the slurry, after this conversion, the slurry which is filled in the lower part of this digester tank. So this digester tank, in above what happens, there is an outlet for the biogas produced, and in the lower part is the outlet for this effluent storage or the slurry storage or slurry digestions, or any you have to either it is drying process of slurry bed or slurry pond, whatever you may call it. So there are two parts here. First is called gas collection, second is the slurry collections. Then if microbiology are involved, because the methanogenesis bacteria, which is the main part to converting the biomass to biogas. So there are mainly four processes for hydrolysis. Hydrolysis means addition of water into the manure. Then in hydrolysis process, these are the chemical reactions have place, because the biomass is nothing but either it is protein, hydrocarbons, and lipids, and it can convert it into small molecules such called amino acids, sugar, and fatty acids. This is the breakdown. First breakdown takes place when you are hydrolyze this manure. Then acidogenesis or acidification takes place. In this process, in temporary produce or bicarbonates or butyrates, some of the decomposition also starts here. Then acetogenesis. This acidogenesis is acetogenesis, which means acetic or acetates are formed and the hydrogen gas is released here in this acetogenesis. And last is the methanogenesis, which is the acetates are again converted into methane. So this biogas is not directly converted to methane. So this acetogenesis and acetogenesis, these are the intermediate reactions happened before this conversion of biogas. So hydrogen gas, this methane gas, and the carbon dioxide gas are the byproduct of this biogas formation process. So there are some literature review or previously detailed studies have been carried out in this type of biogas. What is biogas? So this studies carried out in 2000. That means biogas production using microbial stimulant. They have the effect of microbial stimulant. That means by a shortcut, the main processes behind the biogas formation is microbiology. The two which are studying microbiology, they can go details, equations, details mechanism of this biogas formations, how this methanogenesis bacteria that can be converted break down this bio manure into the different types of methane or other gases. So this is the main some scientists they are studying about this. Then again, there is a study in India that develops compact biogas plant. That means it can technology which can design or optimize to produce the biogas from the annual manure, and they are successfully designed a compact biogas plant which can convert the food waste and this cow dung. Mainly we are using cow dung because in India cow is the domestic animal which can be found in every rural area or every household in village sites, countrysides. So the cow dung manure is the main biomass which can be converted to biogas. So the biogas plant which is designed, and it is very cheap process, not utilize lots of expensive process or lots of money. It is simple process, utilize less cost. So every household have can produce its own biogas and reduce the fuel cost. Nowadays, those LPG cylinder cost 1000 rupees, 1100 rupees. And forget about the wood. You cannot get wood or from forest because forest are having deforestation so much that now it is difficult to find wood to for the mainly utilized for the cooking purposes. So our main substitute for cooking that is either LPG cylinder or either electricity. You can use heater, induction heater because but when you are use electricity, what happen? Your electric bill is very much high. So if you are getting free electric cooking gas in your own countryside, in your own area, or in your own house, that by production of biogas, just you have to add this cow manure, cow dung into the tank by adding water. So in near 2000 to 2010, what happened? India government of India declared some subsidy scheme which can be produce biogas plant in your own house. So even if you go the some village of Maharashtra, there are nowadays they are utilizing these biogas plants and getting its own biofuel or own CH4 or this biogas for utilizing cooking and lighting purposes. Then uh, different feedstock having, if there is 500 gram of methane, 500 gram of methane, you have to add 2 kg of feedstock. If you are having 2 kilo of manure cow dung, then you can produce 500 gram of methane. That means that is one fourth, that is a fourth unit, means produce 500 gram methane, you have to add 2 kg of the manure. So according to you, you have to feed, or you have to feed the slurry, make the slurry to become to continue a continuous source of this biogas plant. Then there are some another studies also. If at the total solid concentration of municipal solid waste, so uh, previously only cow dung can be utilized as the biogas production, but after some subsequent days, we have to utilize the municipal solid waste as a biogas producing unit. The municipal solid waste, that means whatever the solid waste which can be collected by the municipality every morning in your home or in your house, kachre wala aaya, kachre फेंकना, what these slogans, they are just collecting the waste from your home and dumping in a landslide. Rather than dumping in landslides, they have also utilized this plant, biogas plant, for creating biogas. Then a lot of amount of biogas can be produced. So this is the next steps improvement. So this municipal solid waste also utilizing the biogas that can be produce lots of amount of biogas. But the you have to process this through a biogas disaster. Then next some thing, this compared to ratio of the kitchen waste under aluminum biogas plant, that means aluminum made biogas plant, that means the material which is formed is earlier the gobar glass plants which is formed by the bricks and cement. Then uh, some municipal solid waste biogas plant, others are formed by stainless steel, but these are very costly. So if you are utilizing the aluminum based some plants or plastic based, So these microorganisms can be also having high quality of methane gas in this environment. So this plastic creates a lots of environmental problem due to non-biodegradable nature. But when aluminum back painted aluminum is embedded in the plant, then the plastic is also can be degraded in these anaerobic conditions by a certain limited variety of microorganisms and produce the biogas. Okay. So next, what is the utilization of biogas? If you want to produce the biogas, which is the majority component of biogas is methane. So where is the biogas can be utilized? It is utilized in different purposes. Main purposes of utilizing the biogas plant or thus biogas, which is nothing but the mostly the biogas plant, the gobar gas plant, which can be form the methane gas by utilizing the cow dung mainly as a cow slurry. So this is utilized directly taking the pipe from the biogas plant to your kitchen, which is utilized for cooking purposes. It can be used in specially designed burner cooking purposes. So biogas plant of 2 cubic meter capacity is sufficient for providing cooking fuel and needs family about 5 persons. Normally, all family having more than 4 to 5 numbers. So if these 4 and 5 numbers are family, just you have to design a small cow gas biogas plant, the gobar gas plant, which produce biogas mostly every day. If you have two kettles, 2 3 kettles, then you can produce sufficient amount of free cooking gas for yourself and your family. Second is utilization in lighting. Biogas is directly use skill mental lamp for lightning purposes. If you have seen the lightning lamp from directly gas, some mental are used, silk mental then can directly use this gas when it lightning purposes. It gives a very much well lightning. Requirement of gas powering 100 candle lamp 60 watt and 0.13 cubic meter per hour. So this is the requirement, how much gas is required to produce 60 watts of light. So 0.13 cubic meter gas, it is means very small amount of gas can be utilized to produce the light, sufficient light. Power generations, biogas can also use to operate fuel engine to replace 80% diesel oil. That means power generation is nothing but any type of power that may be either mechanical, that may be electrical. So where mechanical power is used, the mechanical power is used mostly in generators and motors or vehicular transmission, where you can use CNG gases or either diesel and petrol for traveling purposes in your car and bikes. So instead of using the fossil fuel, you can directly use this biogas, methane as a source of fuel gas in this transmission purposes. So this, so because you have to replace this oil, special kind of engine should be designed. So diesel engine have been modified into 100% on biogas. Petrol and CNG engine also be modified easily using biogas. So biogas is also high quantity of methane is there. So you can, instead of CNG, you direct feed the biogas which is produced from this biogas plant in place of CNG to run your vehicles. So the biogas can be converted into mechanical power and the power generations is successful. Then electricity generations, you have to boil all steam from this well by heating this process and electricity can be generated. This is also part. Then transport fuel. After removal of CO2, H2O and water, biogas can be converted to natural gas quality for use in vehicles. Because this biogas is 70% methane and 20% is carbon dioxide and 25% is carbon dioxide and at least 5% is the hydrogen and all the different vapors, water vapors and nitrogen gases. So in order to use high transmission fuel, you have to remove these unnecessary carbon dioxide hydrogen gases, but you have to prepare a separate refinery process which can only methane is there, because biogas is 70% methane and the rest are different things. So if it is 100% methane, then the separate unit can be set up to separate these other fuel like other gases like carbon dioxide, H2SO4 and water vapor. So it can be used as a transport fuel for heavy vehicles. So there are different purposes of utilization of biofuel, sorry, biogas. So the biogas are having some process, that is, you have to utilize biogas, you have to store the biogas part. So potential storage of biogas is mainly important. So high pressures is there. If biogas is gas, so in order to store the gas, a high shield is required, like LPG cylinder. In same LPG cylinder you can store the biogas for utilization of any purposes, rather than we are going, if you are using directly biogas from your this biogas plant, though no need to prepare the storage, you can just take out the biogas from the biogas digester through a long pipe to your direct kitchen. Potential biogas is not fully utilized and commercialized so far, because biogas can be produced a less quantity from which can be only satisfy or fuel need for the 4 and 5 people for a family. But when it is not produces in a large amount, that can be feed a total town or large number of people, so it is commercially not applicable for a huge or large amount of people. For commercializations, the area of applications may be redone and cooking fuel and vehicle fuel. So nowadays what's happening? These municipal corporations, they are collecting the municipal solid waste or can be directly converted to biogas. So some larger unit are they have to set up, and commercialization also takes place. So it is for commercialization, this biogas can be refined and stored as a transportation fuel. For use as a vehicle fuel, it should be bottled like CNG or LPG. So this filled cylinder are to be filled to transport fuel. That means they are utilizing for the transport purpose from taking one place to another place. Before bottling, this will enrich methane content from 55 to 95, similar to CNG. As we have discussed, it contains other gases like carbon dioxide, H2SO4. So refinery have to be done, refine has to be done, and the methane content should be increased to 95 to 100%. This is the main things, utilization, and how it can be stored for different purposes. So this is all about biogas, which is nothing but a form of biomass through the biofuel. So biogas is 70% methane, and when it is anaerobically digested through a process called methanogenesis by the methane producing bacteria. So this is called biogas. All about the biogas. First, you have to write what are the how biogas can be generated. That is, what are the compositions. Then production process. So there are 5 process steps are there. Manure collection. Second is digestion, and digestion consisting of again 3 processes, which is hydrolysis, acidification, and methanogenesis. Then effluent storage, gas handling, and gas use. So these are the different process of this biogas. So this is the typically biogas, and this is the pre-testing process. So these are the uses. So this is the all about biogas. Now we can see what is the broader term of biogas, and that is called biofuel. Fuel means you have to something which is going to be utilized for mainly heating and some other purposes. Fuel means for burning purposes mainly. That is direct combustion purposes. Let's see about this biofuels. So biofuels are otherwise it is called as agrofuel. Why it is called agrofuel? Because biofuel, which is mainly designed or mainly found from this biomass, or is a type of bio energy or biomass energy which is derived from the biomass or bio waste. That means anything waste that we are just throw into the landfills or some other composting, we can derive the fuel, and the fuel may be either biogas or maybe biodiesel. last time we have already discussed the fuel, about the different types of fuel. Biogas is a gaseous type of biofuel, and there is another term called as biodiesel. That means the oil seal producing from these bio seal plants, that is called biodiesel. Another type of biofuel is ethanol, C2H5OH, which can be also produced from this biogas. We will discuss these. So all the things, biofuel is also called as agrofuel, because the fuel is produced from particularly agricultural waste, that is like sugarcane waste or paddy waste, rice straw waste. These are produced by this waste, or that is also called as biomass. So this is called biofuels. These biofuels can be used for these purposes, and the main uses of this biofuel for the transportation sector. Transportation sector, that means for transportation or vehicle uses, we have to use this as biodiesel, which is utilized for this combustion engine to transport fuel, and ethanol, which is mostly blended 20% nowadays with the petrol, that is also used as the bio. So the mainly transportation sector. And the important feature of the biomass, that are renewable sources, and that are also mainly substitute of natural size coal and petroleum. So in places of this fossil fuel, the bio fuel may be used. So biofuels, the main sources is this field, agricultural field. Whenever you extract the cereals or the seeds, after the revenue or residue which is just born out, these are the main source of biofuel. So these are waste, generation of fuel from the waste. So today we are using the biofuel and expand throughout the globe, because it is cheaply available the materials, and we can convert it to fuel purposes. Some of the major producers of US are the BioGas and Asia and Europe, America. Biogases are also nowadays various substitute for this biofuel. So there are several factors of decide the balance between biofuels and fossil fuels, because in the world, so these are costly availability and food supply. Because when the biofuel is the main substitute, because bio fossil fuels are limited, and now some after some years we are not taking out, because all all fossil fuels may be over spent over. So we have to generate this. The biofuel are the main ingredients, main resources, renewable resources, which can be we have to dependent on for that. And it biofuels not only gives the fuel, it also produces the food supply. It is a part of the food supply. For example, biofuel is the biogases from the rice and straw fodders, and this sugarcane biogases. So after extracting our food product, the biomass generated is the byproduct. So this actually provides both the things, food as well as biomass. There is only so much land fit for the farming in the world, growing the biofuel and detracts from the process of growing food. So more the agricultural, more the food, more the biomass, more the biogas, more the biofuel. So this is all about this biofuel, which is needs our green energy requirement as well as the food resources or food supply also. So this is a very important. Some agricultural products, they are specially grown for production of biofuel. But nowadays, as the view, the demand of this biofuel, some products or some agricultures which are specially designed for production of biofuel only, not for food purposes. So for United States, soybeans and corns are produced in large quantity, and they are not utilizing for food purposes, only for production of the biomass purposes. Brazil, they are using sugarcane only for not producing jaggery. They are only for producing sugar and can utilize for the production of the biofuel. Europe, sugar beets and wheats are also produced for the biomass production. China, cassava and sorghum, these are the special agriculture they have did to produce this biomass and biofuel. Asia, maize nuts and the palm oils, these are also produced. And India, only jatropha is the cultivatable plant which can be produced biodiesel. The seeds of this jatropha plant are and highly enriched with the oil, and that is the main sources of producing the e-diesel or biodiesel. So nowadays, the gasoline and diesel fuels of some America and Europe countries are blended with biofuels. So nowadays, India also blended 20% of biofuels or ethanol in our biofuels. So dependency of this of biofuel is more, and independent of this by fossil fuel is more. So it is the main thing. That's why we are more focusing towards biofuel or bioethanol, from conversion of the biomass to the ethanol, and that ethanol can be blended into the gasoline or this petrol and diesel. Biodiesel are also part of 3% in some Germany and US market. Now India has also growing more jet turbine plant to more producing biodiesel. Of course, in India it is not account so far. So in foreign countries they are utilizing this biodiesel and this bioethanol all are to replace the vehicles for transportation fuel. 1 billion of gallons of biofuel produced annually. Bioethanol is the more popular, and Brazil produce the world fuel ethanol, because in Brazil and all America they are producing the ethanol from the sugar cane itself. The sugar cane, and they are cultivated or agriculture the sugar cane in large quantity to produce only this bioethanol only. More than 20 billion gallons of fuel is produced in each year. So some fuels are extracted from the from fossil fuel, but the bioethanol are the fluid that can be we are grown in our field. That is the mainly catchy or mainly substitute of this fossil fuel. Ethanol is added to gasoline. Gasoline is nothing but the petrol and diesel or petroleum gases, and some percentage of ethanol is added to improve the content of emissions. That means if you are adding the ethanol, then the efficiency of engine also greater, but the ratio should be maintained, either it is 10%, 5% or 20%. Biodiesel also added the petroleum. So there are mainly two things we are indirectly using from the biofuel as a biofuel. One is called bioethanol, second is called biodiesel. Bioethanol is the bioethanol is the uh, biofuel which can be derived from this whole biomass, but the biodiesel is the biofuel which is produced from the only seed of this bio fuel or bioplants, or the oil which is extracted. But the bioethanol is not the oil, it is the anaerobic digestions of this total biomass which can convert it into bioethanol. So concerns about the global price of food that resulted so many nations and downwards in biofuel production and use. Because somehow in developing country, one work two fruits. That means if you are producing biomass as a byproduct of your food producing, you are doing agriculture and you are getting food as well as this biomass. What are the application of biofuel? Mainly transportation purposes. That is leading application because vehicle require clean, dense and high power fuel in liquid states. So bioethanol and e-diesel both are in liquid form. No gas is there. Biogas is different thing, but bioethanol, ethanol is a pure liquid form. That is alcohol, and pure alcohol, that is you may also call spirit, and diesel, that is combination, so liquid form. E-diesel, that is biodiesel, is also liquid or mainly oil from the extracting seeds of these plants. So both are very easily can be stored and blending with these fuels to produce transportation power. Then power generation, solid biomass like food, wood, which can be generate power. Wood can be burned to producing power or heat. Lastly, heat. So everything, any form of power that can be using the biofuel. So biofuel, there are different forms. First form is bioethanol, second is biodiesel, and third is solid biomass. Directly, when you are burn the biomass, like wood is the biofuel, that means it is producing heat. Biofuel, or it is called as agrofuel, because particularly large amount of this biomass can be, the source is agriculture, the residue of this agriculture. Any fuel whose energy is obtained through a process of biological carbon fixation, that is called biofuel. Biological carbon fixation is the process where the biomass can be converted into biofuel. In case of biogas, it is called methanogenesis process, but it is the biological carbon fixation. That broader term is biological carbon fixation. The carbon present in this biomass, that is in complex form, and it is fixed or it is degraded into small chain, that is called biological carbon fixation. That may be either did in the aerobic condition as well as anaerobic condition. So carbon fixation is the chemistry process that converts carbon dioxide into hydrocarbon molecule and source of energy. This is found in living organism. That means the conversion of process that we are already discussed. What is the carbon cycle? That means the carbon cycle, that is called carbon fixation, conversion of this hydrocarbon and carbon dioxide or carbon monoxide. These conversion of chemistry processes are transferred from the living organism to environment to the soil. So these are biogeochemical cycles involve this carbon fixation. So the converts of the chemistry process is called carbon fixation. And biological carbon fixation means some microorganisms are involved to convert this process. This is called biological carbon fixation. In the presence of some living microorganism like some bacteria, like methanogenesis bacteria, aerobic bacteria, some anaerobic bacteria is there. So with the help of this bacteria, this chemistry or this carbon fixation takes place. That's why it is called as biological carbon fixation. So photosynthesis is the biological carbon fixation process that plant are automatically convert carbon dioxide to oxygen, and this carbon is fixed into our body. That means, see here, this carbon dioxide contains carbon and oxygen. This carbon dioxide is converted to oxygen. That means where is the carbon molecule goes? These carbon molecules are stored as in the plants in the form of fruits, in the form of leaves, in the form of stems, as a source of energy, as the carbohydrate, that is glucose, sugar, fructose, lipid, protein, everything that contains the only the carbon molecule. So atmosphere carbon dioxide is taking in the process of photosynthesis, oxygen is released and the carbon is stored, and thus carbon, which is the main composition of the biomass, and we are again utilize that carbon to produce energy in our this carbon process, carbon fixation process, or that is bio as a biofuel. So this carbon, this extra carbon is utilized by this biofuel. See, this is the main reactions of this photosynthesis process, where glucose molecules are stored in the form of in the plant, and oxygen and water molecule are released. So this carbohydrate, lipid, protein, cellulose, all the things are utilized in the nothing about the form of carbon only. Again, it can be converted to energy form. So this is the biomass. What biomass is? Nothing but any organic matter, which organic matter means hydrocarbon, that is either it is carbohydrate, lipid, or that may be cellulose, anything that is organic matter, that is kernel of hogs, mat, algae, stalks of sugarcane, anything, any dead organism, anything that is from come from the living things, or either plants or animals, that is the organic matter. Type of biomass, first is woody. Woody means coconut shell, palm oil. This is the pine. These are the different woody materials generally born to heat the spaces and they utilize the direct biomass. For example, you are burning direct wood for generating heat in cold days. So this is the direct wood you can utilize for cooking or this generating heat. That's your woody biomass. Non-woody means corn, sugarcane, and bagaces and algae. You cannot use as a wood it is directly, because a large amount of biomass, even in rice straw, on the cereals, corn, bagaces, all the things, soybean, the residue, you cannot be used as a wood. So if this biomass can be converted into either biofuel or biogas to form this different form of energy. So these are called indirect biomass, and which biomass are used directly to generate heat. For example, large wood of tree, those are woody biomass, and the which are we cannot directly use to produce this heat, but they are processed in to convert biomass to biofuel or biodiesel. So these are called non-woody or indirect biomass. Producing biofuel from biomass, the biomass energy converted into liquid biofuels, generally two methods. What are these methods? Already discussed. These are called bioethanol or e-diesel, or that is called biodiesel. Method 1, what happens? Sugars, crops and starch are grow into the process of fermentation, ethanol is produced. When this biomass which is digested and get fermented with the help of some bacteria in aerobic environment, to ethanol is produced. In the presence of oxygens, this biomass is converted to bioethanol. Second method is plants are grown naturally, produce oil seeds like jatropha and algae to get biodiesel. So just biofuel means, remember, either it is bioethanol or it can be biodiesel. Bioethanol are produced from the non-woody biomass or this biomass which is a residue, crop residue, and this biodiesel is produced from the seeds of these plants of this biomass. So these oil seeds are heated to reduce their viscosity after they have been fueled in diesel engine. The oil can be further treated to produce biodiesel, which is used for various purposes. First, oil is extracted like soybean oil, palm oil, biodiesel, jatropha oil. Then again it will be refined various processes, and after some refine go through, it can be directly blended to this fossil fuel or used for vehicle as a motion or mechanical purposes. See, biofuels are counterparts. What are these biofuels are counterpart traditional fossil fuel? These are some biofuels: ethanol, biodiesel, biomethanol, biobutanol. These are the different forms of these biofuels. And what are its counterparts? Where it can be used? So ethanol is used in the form of gasoline or ethane. Mostly this we call as petrol. So ethanol is blended only with petrol. Biodiesel is blended with diesel. Methanol is blended with methane, replaced with the methane, and biobutanol is replaced the gasoline or butane or petrol. So these are the opposite part of the, when compared to the fossil fuel and biofuel, these are the substitute or counterpart of these things. Comparing energy content, the energy content of biodiesel is 90% of that counterpart of petroleum diesel. That means if 100% is biofuel or petroleum fuel, then energy content is only 90%. So the energy content is about butanol is 80% as of gasoline. The energy content of ethanol is 50% of the gasoline. So this biodiesel having higher energy than biobutanol and bioethanol. Biofuel carbon footprint, that is how much environmental problems can be happens or we are degrading environment to produce same quantity of this biofuel as compared to fossil fuel. Obviously biofuels are the greener substitute for the fossil fuel, so this is having less footprint, carbon footprint, and it causes less environmental damage or less pollution as compared to this fossil fuel. So most biofuel are at least energy dense than coal and produce less carbon dioxide than burn. Because the fossil fuel having produced a lot of carbon dioxide, carbon monoxide, all the pollutant when burning, but biofuels are produce less harmful gases when it is burned in the environment. So it is environmental friendly. If it is the, see this is figure, the grown green is, why it is green? Because if the car is car is run with the help of biofuel, that means it produces less amount of toxic gases to environment. That's why it is showing as the green vehicle. See, whenever nowadays, if you have seen electric car, the number plate is green. Why it is green? Because it produce no emissions or less emission. That's why it is green. So this is called green vehicle, which is utilize biofuel as the source of its fuel in place of fossil fuel. That's why it is green. It is greener as compared to the fossil. And also it is renewable. Biofuels produced from the biomass in our agricultural field So every year, every 6 months, we can grow a large amount of biogas, biomass, just by agriculture. So it is renewable, which can be replenished year after by sustainable farming. You just do farming process as agricultural. Every year you can produce lots of amount of biomass, which is can be generated to yield biofuel, and it's a renewable energy. Fossil fuels are requires millions a year, but not renewable. Once fossil fuels or petrol, diesel, or coals are extracted from the mines, it cannot be replenished within the years. So it takes lots of year, or it is non-renewable process. That's why we are now it is moving towards the biofuel, that is main substitutes of the fossil fuel. Although the fossil fuels are higher efficient than biofuel, but we are shifted toward blending of this fossil fuel and biofuel some ratio. So it is also called renewable energy and green energy, because we are producing less harmful impact to the environment. That is called green energy or also renewable energy. So the main thing why it is called green energy, that the main reason is it is renewable and produces less harm or no harm to the environment. Renewable energy other are solar, wind, hydroelectricity. We will discuss all the things in later classes. The green energy is also good for the planet because it does not harm any ecosystems, contribute acid rain or any global warming, because it does not impact our environment anymore. This is the main aim, to utilize the green energy. Solar energy also green energy and renewable energy. All green energy are considered to renewable, but not all renewable energy are green. This is remember. Biofuels are examples of renewable energy, but not always green because they produce greenhouse gases. Whenever there is a burning takes place, some of the biofuels are produce carbon dioxide gases. So that are also not 100% green, but greener as compared to the other fossil fuel because it produces less harmful gases. Woody biomass, these are the examples where we can found the woody biomass. Coconut trees, coconut harvesting edible part, and all the coconut which is utilized after the cells of the coconut are can be utilized for biomass production. Then oil, palm oil. The palm oil also provides different biomass. The fruit produce oil which can be harvested chemically. The biodiesel. Then poplar. The poplar family includes different aspens or cotton woods. These trees are valued for their rapid growth and reasonable for resistance disease. And these can also grow in different desert ecosystems like things. There is even less quantity of waters are there. So they are nothing only requires. Just you have to grow on this field and having the biomass itself. Pine is the valued many some of the regions of polar grown forest, cultivates and inexpensive to grow. You have to just put the seed into the field and you do not even take care it just grow, and the growing of the gives its biomass itself. So we have to just need the biomass, not the fruits and all the things. So this is very much easy to growing the biomass for woody biomass. So there are some history how these biomass fuels are can be produced. Biofuels are not new. We have been around a long having days, but nowadays we are morely active on this biofuel. But previously biofuels are utilized in some less amount because they are mostly depend on the fossil fuel. But nowadays, due to sustainability development, the fossil fuels are we are not more going to be dependent, because one day it will be finished and produce more harmful gases. The biofuels or greener energy are the alternative. So we are moving towards its most. Rodford Diesel, inventor of diesel engine, originally designed to run this vegetable oil, not for the diesel. The diesel engine which were invented are first run by this run for diesel by the vegetable oil, cooking oil. Rather, it is producing the this diesel as a fuel. Petroleum-based fuel are also biofuel and coal, and slowly the fossil fuel and expensive. In the world war, depend on the biofuel increasing, the fossil fuel become less abundant. Biofuel surged the popularity during the energy crisis in 1970. Most recent surge of biofuel popularity occurred in 1990, response to the emissions of standard increasing the demands of the many fuel economy. That means the biofuel is mostly focused due to the monopoly of these fossil fuel countries like Gulf country, Saudi Arabia, Iraq, Iran. They having the monopoly because they having their own mines for this fossil fuel or petroleum only. Because we are importing the fuel from this, whatever the maybe price they have to say, because we are utilizing the petrol diesel car, so we have to force to buy it. Nowadays, whatever maybe you have a scooty or car for petrol run, petrol engine, if the price of this petrol is either 50 or 100 or it may be 500, you have forced to buy the petrol to run over the your vehicle. So the selling person is the monopoly of its own price. If you have an alternative, then the monopoly of these countries, Gulf countries, which are producing the diesel, they are be lost. So in order to that value, we are also focusing towards this biofuel. Ancient 1980s also people also use biomaterials to include the all the things, because old days, as you have seen, we are the main biomass is the main source of fuel in our kitchen. We are collecting biofuel like wood from the forest, and through this wood we are burning the uh, stove using the cooking rice and all these things in our kitchen. So this is not a new thing, but we are mostly having taking advantages and technological advantages toward this biofuel. Ethanol is also used in lightning fuel in 1850. Ethanol means ethanol are some the alcohol which is maybe drinkable in alcohol. Gujarat in the dry state we cannot find alcohol here in legally, but if you are going some different states, alcohol are mostly utilized to drink or intoxicated the people. So this alcohol is also utilized as a fuel, not for drinking alcohol. So these are some different things, or it is long histories there before behind this biofuel. See, there is long history is there. 1990, 1920, prohibition of US control, all the things are there. 1970, interest of ethanol in transportation fuel was received from this oil mergery. Brazil formed Petro Alcohol program. So some their country having own its program towards the shifting of this fossil fuel to biofuels, and these biofuels are the main new green energy which can be generated from this different source of biomass. And this is Canada having United States in partially wood fire turbine plants, biomass electricity generation plants. So all are having large history. So these are the main thing. Then classification of biofuels. Biofuels are classified into three generations. Depending on the quality and the preparation process methods, the biofuels are classified into three generations. What are the three generations? First generation biofuel, which consisting of mainly these sugar, starch, and vegetable oils. Then second generations of biofuels, they are the different forms. Jatropha are called the other seeds which contains oil that gives oil. That are the first generation biofuel. Then second generation biofuels. These biofuels are produced from sustainable feedstock like different forms such as vegetable oil, all these things, and the feedstock. That means the biogases, all the things. Then come to third generation of biogases, that is from biofuels derived from the algae. This is the new variety of biofuel that can be directly derived from the algae. So the algae were considered the next generation of the biofuels, and these are called also algae based biofuels. So if you go in details, we are not going in details about different states. Just remember this three generation of biofuels. Next, advantages of biofuels. Already we have studied that many renewable sources of energy are biofuels, are coal, petroleum, nuclear fuels. The biofuels are greener energy resources. The most way to reproducing producing emissions of greenhouse gases, we are environmental friendly. Then energy density of biofuel is small because as compared to fossil fuel, so we have to again it we have to main thing of research. Advantages: availability of biofuel is cheap everywhere. Every easily can get the biomass and it can convert into biofuel. Less environmental impact is there. Along with the advantage, there are disadvantages. Regional suitability. Some biofuels are suitable in India that cannot be suitable in Canada or cold country like America. Food security, because the biomass are produced along with the food chain or food producing plants. So if you are the sugar can, if we are producing not for the jaggery or food, then it can be create a disturbance of the food security. Land use challenges: not all biomass are the plants are cultivated in same land, but there are different hilly area, small area, wetland area, so not everything are produced in same kind of things. Impact of biodiversity is also there. If you are cultivate this, making agricultural field all over the world, then the biodiversity will be lost, the forest areas will be lost. And global warming, by because the global warming is nothing but the when the methane gas is the mainly a part of the biofuel. If the biofuels or biogas can be leakage down, leakage having directly mixed in the methane can be go to environment, and global warming is that place. This is all about this biofuel. You do not go through all the things. So this is all about this your biofuel energy. Do you have any doubt? Then please ask. This is all about this thing. If you do not have any doubt, then that's all about your biofuel and biomass and biogas. Next class we will discuss more on this sustainable green energy, that is called synthetic energy, synthetic gas.